Hi everybody, and welcome to the Unit 11 trig graphing review video where I'm going to go through a variety of questions in this review packet. I'll scroll through so you can see which ones I have highlighted. So I'm going to go through column A, number 2, number 4, 6, 8, 9, 13, variety of number 14 picked in a certain order. Although I have two number 3s picked, so that's awkward, so I'll figure that out. 15, 17, 20, 23, 24, 25, 26, and then lastly 30. So a good amount of this, not every single question, but I tried to pick a variety that would go through the different topics. Now, there is something to be said about the cover sheet of this review. There is a lot of content on here that's going to be extremely valuable for you all to know. And it's just like a lot of vocabulary that you have to be able to understand and use. Like the amplitude is our distance from the midline. So that's what you guys are seeing right here. And as a distance, it is never negative. So don't ever say an amplitude's like -1. Okay, amplitude is always positive. The period of a graph, which is related to the frequency, is how long it takes to complete one cycle of either sine or cosine. So that would be like one S shape in that sine example. So in this case, the period is pi. Frequency is equal to 2 pi divided by the period. Now, 2 pi divided by pi would be 2, which makes sense because frequency is also defined as how many full cycles you're seeing over the course of 0 to 2 pi. So this example here has a frequency of 2. Phase shift is your shifting left or right. So for example, if you take a cosine curve and shift it to the right pi over 2, this is how the equation would change. And with your sine graph, same idea, shifted to the right pi over 2. You're seeing that midline point move over that pi over 2 units. I think I'll circle these just as a reminder that these are really the same formula, just rearranged. The midline is the average of the maxes and mins. So if you're ever doubting yourself, take the maximum point, take the minimum point, add them together, divide it by 2. That's going to be the equation of your midline. And your maximum can be computed by doing the midline plus the amplitude and the midline minus the amplitude, which you'll see me do today. Just some cute little pictures here, beautiful dance moves, and I'm worried about Mike's obsession between the difference of sine and cosine. Don't worry, it's just a phase. Get it? Because sine and cosine are the same graph, just with a phase shift of pi over 2. You can actually see that right here. So here's your cosine graph, and then if we shifted it to the right pi over 2, now it looks like a sine graph. All right, if you didn't find that funny, that's unfortunate. All right, let's get into the questions. All right, so first thing I'm looking at when I'm given y equals 3 sine of 2x minus pi over 2 is that the frequency is not factored out. So I'm going to rewrite this as y equals 3 sine of 2 parentheses x minus pi over 4. And that's what pi over 2 divided by 2 is, or pi over 2 times 1/2. Amplitude is this leading coefficient of 3. Frequency is 2. And the period is 2 pi divided by the frequency, which is pi. Now your phase shift is going to come from this right here. Notice how it's a minus pi over 4. That means in my chart I'm going to write it as a positive pi over 4, which means you are shifting to the right because that's a positive shift. I have no vertical shift, so there's no up or down there, so none or 0 is sufficient there, which means my maximum value is 0 plus the amplitude of 3, so 3, or 0 minus the amplitude, so -3. My domain of sine or cosine, no matter what, is going to be all reals, but my range is dependent on these max and min values. So my range is going to be from -3 to 3. Make sure you put the low number first and you use hard brackets. Now, when we get into tangent, tangent for a reason is the one that we taught last because he's kind of different than sine and cosine. Tangent has asymptotes involved, meaning places where it's going to be undefined. So if I come over here at just answering some questions, tangent actually doesn't have an amplitude because it doesn't have a distance from a midline. It just forever goes up and forever goes down. The period, though, is pi units. Let's actually get into a graph of it before I explain that a little bit more. What we should do is still mark off every 3 boxes is pi over 2. 2, 3, here's pi, 1, 2, 3, here's 3 pi over 2, here's 2 pi. And I'm going to make every 2 boxes equal to 1 on my y-axis. Now, at odd multiples of pi over 2, so that would be pi over 2 and 3 pi over 2. We're going to put in vertical asymptotes. Tangent, I'll actually start right in the middle of the asymptotes, will cross the midline or x-axis right at pi. When we go a box and a half to the right and go up to 1, that's going to form the right-hand side of my tangent graph. From this intersection, I'm going to go a box and a half to the left and go down to -1. And that is 1 period of tangent. And that's why the period of tangent is pi. Now, I deliberately went in between the asymptotes first just to emphasize that pattern. I still have to fill in here and here if I want to do that interval. So just keep that in mind, okay? So envision this, right? If you're crossing the x-axis here at pi, that means at 0, you're also going to be crossing the x-axis. Box and a half to the right, we go up. You're not going to see the left-hand side of that graph. The other intercept is going to occur at 2 pi. Notice how they're only occurring at multiples of pi. Box and a half to the left, you're going to see the left-hand side of the tangent graph, which goes down. And since we're stopping at 2 pi, you're not going to see the right-hand side. So as I mentioned, our period here is pi units. There's no amplitude. The domain is all reals, except odd multiples of pi over 2, because that's where we put the asymptotes. And that's ultimately because, if you remember from Unit 10, tangent of 90 from your unit circle is undefined, which is why there's asymptotes there. My range, because it's forever going down, forever going up, is all reals. So further emphasizing the domain in the interval 0 to 2 pi, where is tangent undefined? So in this specific interval, that's where I drew the asymptotes. Pi over 2 and 3 pi over 2. All right, so that's a graph of tangent. Now, if I put a, 3 in front of that, okay, I'm not saying I'm going to, but if I were, all that would do is change this point to being at 1 to being at 3. It would be a vertical stretch of your tangent graph. If I made it a 2, then this value would be a 2, and so on and so forth. So just like some transformations that you could see on tangent, probably nothing too crazy, but this is your basic tangent graph. All right, so let's get into some of these multiple choice questions that tend to get students. Particularly, I picked 4 and 6 just as a couple of this type because they tend to confuse students. When x increases from 0 to pi, the value of cos does what? Okay, do not bother even trying to think about this without a picture. Everyone should be able to draw some axes and be like, okay, this is like my general shape of a cosine graph. There's 2 pi, here's pi, which makes this pi over 2, and makes that 3 pi over 2. Okay, so again, this is just a rough sketch. of y equals cosine of x because that's what they're asking me to look at. Now they're saying when you look on the interval of 0 to pi, let's highlight that, 0 to pi, what do you notice is happening? Well, I'm noticing that it's decreasing. So the multiple choice answer is 2. Okay, let's try another one. Now we're going to look at sine, but on this interval. So this one's a little bit trickier, okay? So let's set up some sketches here. This is your basic sine graph. And if I continue that in the other direction, now I have it from negative 2 pi to 2 pi, which means this is pi, which means this is negative pi. Now that means this and this is pi over 2, well, negative pi over 2, and this is pi over 2. I'm just trying to erase that thing to make it better. Okay, here we go. Pi over 2. All right. So if you, again, look on the interval, look at your sketch, from negative pi over 2 to pi over 2, what do you notice is happening? Well, from left to right, I'm thinking that graph is increasing. So the correct answer is option 1. Okay, so there's a couple extra problems there that you guys can try and then check the answer key, but ultimately that's what you have to do. Draw a picture, label those little intervals, and then just look at the graph and tell me what's happening. If you try to do this without drawing a picture, I don't know why you're trying to make your brain hurt. Okay, draw a picture, make sure you get the question right. Now, question 8 asks me basically to come up with the range. It says a value that is not in the range is what? Well, first of all, let's even figure out what the range is. Now, this is really important to know. The range of any trig graph, sine or cosine, any sinusoidal graph, is the midline plus or minus the amplitude. Okay, it's always based on your distance from the midline. The midline in this problem is 2. The amplitude is positive 3 because remember, amplitude can never be negative. Is there a reflection in the x-axis? Sure, but that's not relevant to coming up with the range. So if I do 2 plus 3, that gives me 5. If I do 2 minus 3, that gives me negative 1. So that means my range is negative 1 to 5. So anything between those values and including those values is in the range of my graph. So 5 is definitely in it. Negative 1 is definitely in it. Negative 2, well, isn't that lower than negative 1? And 3 is definitely in there. That's between negative 1 and 5. So the one that's not in the range is question 3. All right, last multiple choice here. At x equals pi over 2, the difference between 2 sine of x minus 2 sine, or cos 2x is what? Okay, so first of all, they're saying take pi over 2 and substitute it in for x. So let's do that. So this would be 2 sine pi over 2 minus cos of 2 times pi over 2. Now, if you don't want to think about it in terms of radians, you could do degrees, meaning this is 90 degrees and this would be technically 180 degrees, or again, keep it in terms of pi. It doesn't really matter as long as you know what you're looking at. So I'm just going to clean this up a little bit. Okay, so ultimately I'm looking to evaluate, hey, what is sine of pi over 2? What is cosine of pi? Now, guys, you could find this answer from the unit circle like we did in Unit 10, or sketch a picture. This is your sine graph, right? Pi over 2 is right here. What's the y value? That's 1. Okay, let's sketch your basic cosine graph. Okay, this is pi. What's the y value? Negative 1. So if you go to substitute in, you have 2 times 1 minus a negative 1. So your final answer is 3. Now, if I'm being truly real with you guys, you really could just type this in your calculator, but just be conscientious of your mode. If you're typing it in with the pi's, make sure you have your calculator in radian mode. If you're typing it in degrees, then put it in degree mode, okay? So however you want to do it, you really could answer it with a calculator if you're in a bind, but it's all coming from the graph. All right, let's get into a word problem. The Sea Dragon, a pendulum ride at an amusement park, moves at its central point of rest according to the trig function p of t, where t represents time in seconds. What is the period? And what does that mean in the context of the problem? So I'm sure you guys have all been or seen the type of ride this is talking about. It's one of those, like, you know, kind of looks like this. They're usually like boats or something. So they're calling this like the Sea Dragon. There's a flag or something. And it just like swings back and forth, right? Okay. So the period would represent going forward and rocking back in one cyclic motion. Okay. In this case, it's doing it in terms of sine. All right. So the period is always equal to 2 pi divided by the frequency. Notice how our frequency is in terms of pi. So if I rewrite this using keep, change, flip, my pi's would reduce, and this would end with 6, and in the context of the problem, seconds. So what does this mean in the context of the problem? This means it takes 6 seconds from start to finish here to have one full cycle on the ride. Okay, I'm not going to write that down. You can get that from the key, but that's what it means. It takes 6 seconds to complete one full cycle on the ride. So like I said, that's like you guys going forward, returning to the starting place. That's 6 seconds. All right, moving on to all these different little trig graphs. You'll notice that I picked like an order for myself that I wanted to go through based on, in my opinion, some difficulty level. I'm going to use hot pink. Okay, so first thing I can do in really any of these is figure out the midline for each. So like this guy is very obviously going between 3 and -3, which means the midline is 0. Same idea here. This is going between -1 and 1, which means the midline is 0. That's just the average of those points. Now you'll notice here in number 3, this one has a maximum of 1. And I believe the minimum, yep, is -3. So add those together, that would be -2. Divide by 2 is -1. So here's your midline. Okay, same idea. This looks like it has a maximum of 2 and a minimum of -4. So that's -2 divided by 2, which is -1 again. Okay, and then same idea down here. This is here, here. I hate the way this one is. It's 1, 2, 3, 4, 4, and -4. Yeah, so this one also has a midline just at 0. You know what? While I'm at it, let's do the midline here. This one's actually kind of nice because it starts right on the midline. There you go. It's always good to identify your midline, in my opinion, first, before you consider all the other things. Okay, let's start with E. So if I want the equation of E, first impressions with respect to your y-axis, you are starting on the midline. So what that tells me is this is a positive sine graph. My amplitude is 3. My frequency is how many cycles I'm seeing between 0 and 2 pi, which they have marked for me. 1, 2. So putting this all together, this equation is y equals 3 sine of 2x. All right, now the next one I want to do, down here at C, with respect to the y-axis, I'm starting on the midline. Notice how the y-axis is oriented in the middle of the page. Okay, so that's a little tricky there. So I'm thinking this is a positive sine curve because it's going up first. Amplitude is 1. Now, frequency again is interesting here because I'm giving you 0 to 2 pi. Right there. How much of the sine curve am I seeing? Well, that's only half of it, right? So that means my frequency is 1/2. So putting this all together, y equals sine 1/2 x. Okay, so I deliberately started with those because they didn't have any vertical shifts up or down. Now I'm at number 3 where I definitely have a vertical shift. Okay, now my amplitude is the difference between the maximum and that midline. So the maximum's 1, midline's -1, I'm seeing an amplitude of 2. Now with respect to the y-axis, we are starting above the midline. So that means this is a cosine graph. And since we're starting above the midline, it's a positive cosine graph. Now I'm going to zoom in here because this is a little tough to see. Okay, they're telling you 2 tick marks here is pi, which means this is 2 pi. So if you look from here to here, how much of the cosine graph are you seeing? I'm only seeing half of it, right? Because shouldn't it look like a full cup like that? So putting all of this together, I'm thinking the equation is y equals 2 cos 1/2 x, and then don't forget our midline, which is down 1. Okay, so I did 1, 2, 3. Oh, we got to go back up here now to 4. Okay, again, with respect to your y-axis, we are starting below the midline. So that means this is a negative cosine graph. Amplitude looks like it's 3 units away. Midline is -1. Now, what is the frequency here? So this one's kind of interesting. Based on what I'm giving you content, if you will, between -pi/2 and pi/2, which is pi units worth of content, if you will. So that means if you actually follow, try to pick a nice color here, maybe this navy color. No, that's not great. I'll just use red. Okay, if you follow over that pi units, I'm seeing 1 full cosine curve from max to max. That means if I'm seeing 1 cycle over pi units, over 2 pi units, I would be seeing 2. So that means my frequency is 2. And that's just one way to think about it. Some students will say, well, you're only seeing half of a cosine curve in 90 degrees. I really want 360 degrees, so times 4 would also give you 2. So putting all that information together, y equals -3 cosine of 2x. Again, don't forget your vertical shift, so -1. All right, coming on over to k. Okay, now k is a toughie one, and this is one where you're going to have to add in a phase shift, and there's technically a bunch of things you can do, so I'll probably explore at least 2 of them. Okay, I'm going to erase this midline just to make this more obvious here. Okay, the midline's 0. So let's see. With respect to the y-axis, we're not starting at a max, a min, or the midline, so we're going to have to do a shift in here. So let's actually pick a point like this. Okay, that's a shift to the right. Well, if this is 90 degrees, that means this is 60 degrees for 2 tick marks, which is the same thing as pi/3. So that's a shift right of pi/3. Now, if you actually follow from that point on, that looks like a negative sine curve, right? So if I want to write this as a negative sine curve, okay, I am having an amplitude of 4, because that's my distance from the midline. And from maximum to maximum, so here to here, based on your scale, you're actually seeing 2 pi as the period, which means the frequency is 1. You're seeing 1 full cycle in 2 pi units. That's the frequency. Okay? Now, like I said, this is going to be a negative sine curve with a phase shift of right pi/3, because you have to envision your sine curve looked like this originally, and then they just shifted it to the right. Okay? So putting all this information together, my equation would be y equals -4 sine of x minus pi over 3. And that's a right pi over 3 shift. Now, as I mentioned, that's really just one option here, okay? I'll do another color, okay? What if you wanted to write this as a cosine curve, okay? I would probably start there. That's a maximum point. And that would be a shift left 1 tick mark, which is the same thing as 30 degrees, which is pi over 6. So again, that's left pi over 6. Now from that point on, that does look like a positive cosine curve. So this would be a, get back my green pen, positive cosine curve, amplitude still 4, frequency still 1, that hasn't changed, so I'm just going to put it all together. Y equals 4 cosine of x plus pi over 6. And then you're done. Okay? Now, technically, I really could have done a bunch of different options. I just picked the ones that were closest to the y-axis. So, like, if you wanted to do a negative cosine curve, you'd want to start at a shift of 150 degrees, whatever that is in radians, okay? Because that was like 180 minus 30 there, if I'm doing my quick math correct. That would be a negative cosine curve. I mean, you guys could have done a sine curve right here. Oh, wait, no, I did that one. Never mind. Okay, I did that one. You guys could have done a sine curve here by doing that shift, by picking that intersection. You could have done a negative cosine curve here. But again, those are probably the harder ones to do just because they're further away from the y-axis. So I tend to just pick the ones that are closest. Okay, so that's 2 ways to write the same graph, giving you guys some options. Now, I've picked or maybe that's L. Yeah, it's an L. Deliberately here because notice how the x-axis is in terms of a regular number and not pi. When the x-axis is in terms of pi, you guys are going to see a frequency in terms of just a regular number. It's the exact flip when you have the x-axis in terms of a number. So good news is we already figured out the midline, so that's like one less thing to deal with here. Our midline is 200. I'm just going to write that down. Our amplitude, which is the distance from the maximum to the midline, is going to be 100. Okay, so let's get into how do I figure out the frequency. Frequency is always equal to 2 pi divided by the period of the graph. So how long does it take you to see one full cycle? One full cycle looks like that, which is 32 boxes, agreed? So that means when I do my substitutions, my frequency is 2 pi divided by 32, which reduces to pi over 16. So this looks like a sine curve. It's starting on the midline. In fact, it looks like a negative sine curve. So putting together all the pieces of the information that I have here, I would say the equation is y equals negative 100 for that reflection, sine of pi over 16 x, and then don't forget your vertical shift of 200. All right, last question I'm going to do on this page is question 15. This is a multiple choice taken off of a final exam that tends to get people. It says, which graph represents a cosine function with no horizontal shifts, an amplitude of 2, and a period of 2 pi over 3? All right, well, first of all, they're looking for a cosine graph with no phase shift. So that means I can eliminate 2 and 4 because those are starting on the midline, meaning those are sine curves at the y-axis, okay? Now I'm between 1 and 3. So you've got to think about what the definition of a period is. Period is how long it takes to complete a cycle. So if you guys look at your graphs, okay, you are seeing one full cycle here happening in some time less than pi over 3. Look, they actually have 2 pi over 3 mapped out for you. I'm seeing 1, 2, 3 cycles in that time. That's too short. That's not the period. The period would imply that you see only 1 over that course of time. So that one's out. So by process of elimination, you can get 3. Now, here's another way to think about it. The frequency is equal to 2 pi divided by the period. So if you do 2 pi divided by 2 pi over 3, That's the same thing as 2 pi times 3 over 2 pi, which is a frequency of 3. That means you are seeing 3 full cycles over 2 pi units. Hey, look at that. There's 2 pi. 1, 2, 3. That is what that's describing. That has a period of 2 pi over 3. And that's your multiple choice answer. All right, moving on to question 17 on the next page. We're just going to graph one cycle of the trig function given. And I picked this one because we really threw the whole kitchen sink at you. You have all the things to look at. So I like to list out what I call my ABCs of graphing. A is my amplitude, which is 3. B is my frequency, which is 2, which means the period is 2 pi over 2, which is pi. My phase shift is pi over 6, which, keep in mind, that means you're moving to the right one box when we graph. My vertical shift is 1. Now, it may also be helpful to come up with a max and min when you're graphing, and that's always the midline plus or minus the amplitude. So that's 5 and -1 if you want to keep those in mind. All right, so I'm going to pick a color here, maybe purple. I'm going to throw in my midline and label it. And then label my axes. Okay, now with graphing a sine curve, normally we would start right here on the midline, but remember how we said everything was going to shift right one box? So we're actually starting here. Okay, maybe I'll do like pink to make that stand out more. Okay, the period is pi, which is 180 degrees or 6 boxes. So once you have your starting point, you can just count out 1, 2, 3, 4, 5, 6. That's the beginning and end of one cycle. Don't look outside of those points. From there, what's half of 6? 3. So 1, 2, 3. Now you're on the midline again. Now, don't forget, we do have a reflection in the x-axis, so that means it's going to go down first. So when I go a box and a half, I'm going to be in the middle, and I'm going to go down to -1 because my amplitude is 2, or my amplitude is 3. Okay, I just realized I made a mistake. Why did I say the midline was 2? The midline's 1. Hold on a second. I was like, that doesn't make sense, because then the amplitude will only be 2. My bad. All right, so if you were looking at this being like, oh my god, what's she thinking? I wasn't. Okay, so 1 plus 3 is 4, -2. That makes way more sense. My bad. Okay, so we're box and a half, and then we're going 3 units below, because that's my amplitude of 3, and so we're going to -2. Probably should have mapped this out first so that I had a better idea. Right, that's 4 units away. Okay, so then box and a half, I'm going to go up. And there you go. Connect your 5 dots. And that's your negative sine curve with an amplitude of 3 with the correct period and the correct phase shift. Now, I'm not going to do 18, but the one thing I do want to have the conversation about is that the frequency is not factored out here. So just make sure before you proceed, you factor it out, because there is actually a phase shift of -pi over 2, not -pi. And in that case, that would be left 3 boxes on our scale. All right, our next question is going to involve a Ferris wheel. So I am going to draw a quick little sketch of it. All right, so you go to the carnival and decide to take a ride on the Ferris wheel. The wheel is 4 feet off the ground and has a diameter of 38 feet. So I'm going to label that here. So 4 feet off the ground, diameter, which means the full width or height of that circle, is 38. The wheel decides to make a revolution. I don't know why I said decide. The wheel makes a revolution every 10 seconds. So that right there, they're telling you the period. All right, so just keep this in mind. 38 plus 4 is a maximum of 42. So at your highest point on the Ferris wheel, you're hitting a max of 42 feet off the ground. At your lowest point, which is when you get on the wheel, you're going to be at 4 feet above the ground. Okay, so let's jot that out here. Now, it's important to use that max and min because I can come up with the midline from that, which is just the average of those. My amplitude is always the maximum minus the midline, which is 19. And they told me the period is 10 seconds, which means the frequency is 2 pi over 10 or pi over 5. Now, when you get on the Ferris wheel, you're going to get on at the bottom of the wheel, which means you're getting on below the midline, which means this is a negative cosine curve. So this is like your general form, right? A cos bx plus d based on what I just found. And in fact, since I know I'm starting at the bottom, I'm just going to throw a negative in there. Now I just need to plug in the information that I found. And that's your equation. So now we're going to graph it. Now, keep in mind, we said the midline was going to be at 23. So I'm going to find where that is here. Make it stand out in purple. I wish I had a straight edge, but we're freehanding it. All right, so y equals 23 is my midline. Now, you're starting at a minimum of 4 again, right? So we're going to come down here. Here's my minimum. God, I think I have to zoom in here. This is kind of hard. So this is 2, 3, 4. There's my minimum, which means, remember they said the period was 10 seconds. 1, 2, 3, 4. Okay, so that's the start and end of one cycle. What's half of 10? 5. That's where you're going to hit the maximum. Now the maximum we said was 42. Oh my goodness, this is hurting my eyes. It's so much better not on the computer. So the top value, let's see, I think this is 42. Did I get that for 5? Yes. All right, what's half of 5? 2.5. So we'd be like right in here would be my midline. Okay, 1, 2.5, midline, and then a nice smooth curve here. All right, and there you have it. That is my one sketch of the cycle of cosine. All right, next for question 23, very similar to the last example, we're going to come up with an equation that represents the data being given. The number of hours of sunlight on day 1, which is the longest day of the year, is this 13.976 number. The number of hours on day 184, which is the shortest day of the year, is 8.417. Cycle is repeated every 360 days, aka 1 year. That's what we're looking at. Find a sinusoidal function that matches the data. Now, sinusoidal can mean sine or cosine, whichever we feel makes the most sense. Now, they're saying on day 1, they're starting at the longest day, which means we're starting at a max. So we're going to represent this as a cosine curve if we're going to start at a maximum point. Okay, now I can use the numbers they gave me, which was the maximum and the minimum. Okay, here's the minimum, here's the maximum, and if I add them together and divide by 2, I would get 11.1965. The amplitude is always the max minus the midline. So again, my maximum is this 13 number. My midline I just found. So that would give me 2.7795. Frequency is 2 pi divided by the period, and they told me the period was 365 days. So putting all this information together, again, I'm going to use a cosine model because we're starting at a maximum. I have y equals 2.7795 cosine of 2 pi over 365x plus my midline of 11.1965. Part B says use this function found in Part A to predict the number of daylight hours on day 284. So all we're going to do is take day 284, and substitute it in for x. Now, something to note is that because my frequency is in terms of pi, we're going to make sure our mode is in radians when we type this in. So I'm going to put a little note here. All right, so I paused the video and started typing this in, although I noticed I just typed this wrong, 11.1965. Okay, my calculator is in radian mode. Look at how I type this in. I have the 2 pi over 3 there, 2 pi over 365 typed in, times the 284. And there's my cosine, and I'm just going to hit enter. So 11.684 ... hours. I don't have a rounding direction here, so I'll just leave that for now. That should be sufficient. All right, cool. Question 24. So we've done one of these before. I'm going to do one more of them. I'll just do the one on the left. Okay, I want to write a sinusoidal equation for the following. Now, with respect to the midline, this looks like a positive sine curve, right? With an amplitude of 2. Okay, but the frequency is not going to be in terms of pi because my x-axis is in terms of a number. Or excuse me, I said that wrong. My frequency will be in terms of pi because my x-axis is in terms of a number, just a regular number. So let's figure out the period. You can just pick 2 maximum points and see how long it takes to complete that one cycle. So on this, the period is equal to 12. Okay? Now, frequency is always computed by doing 2 pi divided by the period. So that reduces to pi over 6. Now, like I said, this is going to be a sine curve, and there's no vertical shift, so putting this all together, y equals 2 sine of pi over 6x. Okay? Now, I accidentally misspoke before, so I want to make sure I clarify. Notice that when the frequency is in terms of pi, the x-axis is in terms of a real-world number. It's always going to mismatch. All right, question 25 is a tricky one because it says which of the following is not an equation that matches the graph below, and we've deliberately put in some phase shifts. So let's go through them. Okay, the first one says this is a positive sine curve that's been shifted to the right pi over 3. Right pi over 3 would be right here, and that's a shift to the right. Now, this does look like a sine curve that has been shifted to the right pi over 3 units. That's 2 boxes, so that actually is true. Now, this says a negative sine curve, but it's been shifted left pi over 6, which is 1 box over. All right, so this is left 1 box, and if you look at the pattern from thereafter, that actually looks like a negative cosine curve, not a negative sine curve. So that's your culprit. That's the false one. Now, technically, the other ones are valid. If you look, this is a shift left 2 pi over 3, 4 boxes, 1, 2, 3, 4. That's this right here. From that point on, that actually does look like a negative sine curve. okay? This would be a shift to the left 1 box. And there it is. There's that -3 cos I told you I was looking for, and that's why that one's true. So yeah, these are each true. Your false one is B. All right, so in the movie Toy Story, Buzz Lightyear bounces off a ball to help him fly, and the distance from the ground in inches can be modeled by this equation, where x is the time in seconds. We're going to graph 1 period of Buzz's flight. So if you remember in the movie, he stands on like a bookshelf, and he like kind of jumps off and bounces back up. The ball's like here, let's say, and that's what's helping him fly, okay? So if I go through my ABCs of graphing here, my amplitude's 14, my frequency is pi over 5, which means the period is 2 pi over 5, which is 10. Now, the midline is at 22. So if I want to graph this, I'm going to put in my midline first. Equals 22. Now, he's starting at a maximum because this is a positive cosine curve. The maximum is going to be 22 plus 14, which is 36. So you're starting here. That means 10 seconds later, which is the period, he's going to end at 36. Now the minimum is the midline minus the amplitude, which is 8. So if his flight was 10, half of that's 5, which means at 5 seconds, he's hitting 8, which is where we can assume the ball is that he's bouncing off of. All right, now halfway, halfway, halfway. Okay, so half of 5 is 2.5. So like right in here, in the middle of the box there, you're going to be at the midline, which means 2.5. From the end of the cycle, we're on the midline again. There's your 5 major points. One nice smooth curve, doing the best I can with my stylus here, which I feel like is not too terrible. There's your graph. So at what height is he hitting the ball? Like I said, we can say 8 feet. Oops, nope, not 8 feet. Sorry, it's 8 inches. Double checked my unit there. And what is the period? Well, we said the period is 10 seconds, which is the time it takes Buzz to fly and return to his maximum height. I'm not going to write that, but you can see it on my answer key. What's the maximum height he's going to reach? That was the 36 inches that he actually was starting from I think the dresser, and then he bounces back up and he flies up to 36 inches. All right, this is quite a long video because there's a lot of content, but this is my final question to go through here. So question 30. The Sky Wheel is a Ferris wheel in Niagara Falls. True statement. It has a diameter of 54 meters, and it has a total of 42 gondolas that can each hold 6 passengers. Okay, cool. The height of the gondola can be measured by the function h of t, and t represents time in minutes. Assuming you get in the gondola at the bottom of the wheel, how high are you above the ground? They're asking you, what's the minimum height? Well, the midline is 29 and the amplitude's set 27, so you're getting in the wheel 2 meters off the ground. So right there, that's 2. Okay. How long does 1 revolution take? Well, they told me, where was it? Oh yeah, the period is related to the frequency, right? Period is equal to 2 pi divided by the frequency of pi. So this is a 2-minute revolution. So that means going all the way around from start to finish is going to take you 2 minutes. How high above the ground will you be 9 minutes into the ride? They're telling you a time t there. So ultimately you're just doing h of 9 in your calculator. So negative 27 cos of pi times 9 plus 29. Now, if you want to plug that in your calculator just like so, make sure you're in radian mode. But if you plug it in degree mode, you would have to change that pi to be 180 degrees. So whatever you want to do, but be conscientious of what you're typing in. Ultimately, you're going to get 56 meters off the ground. Algebraically determine when the gondola will initially, meaning first, be 50 meters off the ground and round to the nearest hundredth of a minute. All right, so that means this 50 meters we're going to set as our height. Now, I'm going to change this to 180 degrees T, just so that I can use my calculator in degree mode. I want to solve for T. So first thing I'm going to do is try to isolate my cosine function by subtracting the 29, and that gives me 21 equals negative 27 cos of 180t. So that means I can divide by negative 27 and get 21 over negative 27. Cosine of 180t. Now, at this point, I need to undo cosine, which means we're going to use inverse cos. And whatever that will do, will undo cosine and leave me with that equal to 180t. So let me grab my calculator. Now remember, I changed it to 180 degrees, so I'm going to need my calculator in degree mode. Okay. So I'm undoing cos using inverse cos. So that's negative 21 over 27. And I'm getting this 141 number. Now remember, in order to solve for t, you're going to have to divide by 180. So I'm getting 0.7836. Now my rounding directions say nearest hundredth. So t is equal to 0.78. As my final answer. So what were we looking for? We were looking for at what time you'd be 50 feet off the ground. So that is 0.78, technically of a minute, because that's what we were looking at. And that concludes this very long review video. I hope it helps.